Assalamualaikum warahmatullahi wabarakatuh. We will start our class in shortly. So for the audience, all the participants, hopefully you can focus to listen the course. Okay. Good afternoon, everyone, lecturers, students, and all the participants. Welcome to the third session of International Online class organized by Faculty of Engineering and Science, Universitas Ibnu Khaldun Bogor. So it is my honor to be a moderator for this session. And also it is my honor to have Dr. Fauzan Aziman here with us this afternoon. So Dr. Fauzan will deliver a talk entitled Engineering the Future Strategy to Build EV Ecosystem, Electric Vehicle Ecosystem in Indonesia, and how to be part of it. So as for the beginning, I would like to invite our Dean, Dr. Insinyur Haji Muhammad Nanang Prayudianto, to give the opening speech. To Dr. Muhammad Nanang, the stage is yours.
Thank you, Dr. Fitriani. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Let me share my file. Okay, thank you for joining us. This is the international short course between Oxford University and Ibnu Khaldun in Bogor, in Indonesia. So it is a moment of extreme pleasure to welcome the guests who are present here to attend this international short course. On behalf of the institution, I offer my regard to all lecturers and the students joining us. I convey my regard to the guest lecturer of the day, Dr. Fauzan Aziman, Engineering Director of Allowed Limited, Department of Engineering and Material, Oxford University in UK. As we know that OICA is one of the growth university in Indonesia to a global level and ranking 75 based on Science and Technology Index. OICA vision is to be leading university based on Islam and technology in 2025. And we know that Oxford University is one of the top universities in UK and the world. I'm sorry. We have the third session here, the first in March, second in April, and I think we have the third one in June. The topic is robotic intelligent machines and material engineering. The participant is student of Faculty of Engineering Science. The center is Oxford lecture and UK lecture, and duration 2 hours. So in this session, we collaborate between Oxford and UICA Bogor. Topic is engineering the future strategy to build EV ecosystem in Indonesia and how to be part of it. Dr. Fauzan Aziman is guest lecturer and Dr. Fitriani is the moderator. And I just understanding that EV objective is to reduce energy consumption and to improve environment. So as we know from the picture, we like to reduce the energy consumption and comparing the different type of energy of the vehicle. And now in Indonesia, we already start the last year and the recent year, we have many cars from other countries coming the traffic to Jakarta, from Korea and other countries like China. I saw here the comparison between ICE, hybrid, plug-in hybrid EV and battery EV and fuel cell EV. Now I think the objective is we have to go to battery EV, which we use a motor and battery full size. And this comparison in Indonesia, I think Dr. Fauzan is the expert. So, and I say here that Indonesia has good opportunity to develop EV. Why? Because we have the raw material I think in Morowali, the central Sulawesi, we have material like nickel and lithium there. We have also the refinery refining the product of nickel hydroxide and cobalt hydroxide. And the other location is Weda, Halmahera, Indonesia, parking. So we have to manage battery manufacturing, the cell manufacturing and park assembling. We have also domestic manufacturer here, yeah, and a private or SOE. So from that potential, I think this topic of seminar is very useful for us as a nation, citizen, and also the student and lecturer to look at the challenge that we now have many technology here. I think the company also there, and that's why the policy of government in Indonesia to use MBKM is to join between university and industry. So we learn from industry how to catch up the technology. I think this is useful, and thank you, Dr. Fauzan, for your time and your knowledge to sharing with us. So as faculty of engineering science, I think we can start the short course by Bismillahirrahmanirrahim. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Muhammad Nanang, for the opening speech. So before we begin our class, may I briefly introduce our guest lecturer? So Dr. Fauzan Aziman completed his bachelor degree in Mechanical Engineering Department, Bandung Institute Technology or ITB in 2003. Then he completed Master of Engineering in Mechanical and Controlling Engineering at Tokyo Institute of Technology, Japan in 2007. He also earned the Doctor Philosophy in Computational Material Engineering, Zinkowitz Center for Computational Engineering in United Kingdom, UK in 2014. So currently, Dr. Fauzan serves as engineering director and also the co-founder of Alloyd Ltd. So the Alloyd, formerly Oxmed Technologies, was spun off from University of Oxford to downstream and fast-track commercialization of digital solution to material and also the manufacturing technologies. Besides this role, Dr. Fauzan also served as Vice Director of Next Generation Tatara Center, or NEXTA, a national R&D center built in Japan. He also an academic visitor at Department of Material, University of Oxford, an adjunct professor in the Faculty of Mechanical and Aerospace Engineering, ITB, and a member of Indonesia Green Energy Team. So that is a brief curriculum vitae of Dr. Fauzan Aziman. We have approximately about 50 minutes for these sessions. So perhaps Dr. Fauzan will deliver a talk about 45 minutes and then followed by approximately 5 minutes for the Q&A. So to the all audience, you can ask the questions by typing your question in the chat box in the bottom of your Zoom application, or later you can ask by raise your hand in the Q&A session. So don't be worried because this class will be conducted in two languages. So maybe combination between English and Indonesia. If you don't have any difficulty in writing the question in English, you can type in Indonesia. So without further ado, I would like to invite our guest lecturer, Dr. Fauzan, to deliver the talks. So Dr. Fauzan, the time is yours.
Thank you very much for Pak Nanang and Bu Fitri. So my name is Fauzan. I'll share my screen. So is my screen visible?
Yes.
Yeah. Okay. So thank you for the invitation. It is a great honor for me to be invited and then be able to discuss about a topic of my interest, and then hopefully also of interest for everyone joining this lecture. My name is Fauzan. I'm based in Oxford at the moment, so it's a very early morning. It's quite nice early morning here. About 6 hours difference between Bogor and Oxford, and I've been in Oxford for the last 9 years, and then been overseas since around graduations of my undergrad, so for the last 19 years or so. But even though I'm living in abroad, so I do still communicate with Indonesia frequently, and then also visit Indonesia. So I think this is probably something that I can share, that if you are abroad, not necessarily leaving your country, but you can also still contribute to your country. So hopefully, if any of you has interest to go abroad and then to study or work or anything, so we can still be part of the Indonesian community. And then one of which is a topic that I've been working on, is building electric vehicle ecosystem in Indonesia. And one part which I think of interest is then how we want to be part of it, especially for young engineers. So we'll also have that sessions discussing some strategies that you could probably learn and also discuss with me. A little bit of my background in terms of my activities. So yeah, whilst I'm explaining my background, showing a video of Oxford University. So Oxford University is an old university located in Oxford, about 1 hour from London. The university itself is established around 1100 year, so around 900 years ago. So it's a very old university. We don't have that many engineering science students. So every year we only take around 170 engineering science. Engineering science means that all the part of engineering, including electrical engineering, informatics, and then mechanical, civil, and so on. So I joined Oxford in 2014, as explained by Dr. Fitriani. And then since then, I work as researcher and then lecturer. And in 2016, I established a company called Alloy, which I will explain. And then from 2018, joined also as adjunct professor at ITB, where I've been allocated to work with green energy team in Kemenko Marves, Indonesia, working with the team in Indonesia to accelerate implementations of electric vehicle in Indonesia. So I will explain a little bit about my background or activities that I've been doing here in the UK. So hopefully this could give you a little bit of a flavor of what type of activities that an engineer can do. So when I joined Oxford in 2014, I just completed my PhD at that time. And then I joined a center called Rolls-Royce University Technology Center. So we built a jet engine, the one as you see on the left-hand side. And then this is a jet engine that I was part of the team, so building this Trent XW engine. And then in 2016, 2017, I started working on a different type of engine, which is called G9X engine for a new fleet. We don't have that many now. It's called Boeing 777X. Before coming to the UK, when I just graduated from ITB, I used to work in oil and gas. So you can see as an engineer, we can move from one field to another, so long that your field is something that you are interested in. So this is also something which I can share. So you don't necessarily need to stick to one product or one engineering components, but you can also explore yourself to a variety of interesting development in different industries. And then when I moved to the UK, so in 2016, with 4 of my colleagues, we spun out a company. So it's called Alloy. At that time, the name was Oxmed Technologies. So Alloy is a company focusing on digital manufacturing. So I will explain what is digital manufacturing a little bit later on. Alloy headquarters itself is still in Oxford. So that's the reason why I still live in Oxford. We do have other offices, overseas offices. So we have offices in Tokyo, in Japan, and also in Los Angeles in the USA. We work in a number of different fields. In aerospace, similarly what I showed before, and then in energy, motorsport. So we're working with high-end motorsport company, F1. We also develop a component for orthopedics, for biomedical implants, all of which are 3D printed. So the 3D printing is the part where the digital manufacturing is. We've been also working in the electronics field, where we build wearable like this, as you can see on the picture. So something that relate to you now, probably when you look at the way how Meta is developing. So we are a supplier some parts to Meta for their virtual reality, augmented reality side. So the key of what I've been doing in my field of work is to see how ideas evolve into concept, innovation, strategy, and then commercialization. So let's see the idea and then how we can turn that into commercial aspect. So at the moment, so we start in 2016 with 4 people, and then at the moment we have 130 people in the company across the globe. And then we've been working with a number of exciting companies in the world. So these are just some people within Alloy. So as you can see, we are a very international team, which means that anyone can join in. So if you passionate about your field, and then you want to become the best of your field in the world, so this type of environment may help you. And then I just want to show this as one examples of this type of engagement in the international world. So hopefully this motivate you once you graduate, for students, that the field of opportunity is wide, and then you can be what you want to be, so long that you work hard and be the best of yourself. And hopefully this excites you, that not only if someone's going into, say, master's degree or a PhD, they don't necessarily need to go just to the university. You can also be part of the industry or be part of both. So in my case, I am in the kind of working in the both worlds at the same time, with the hope that all of this can lead to some product development that we can develop in the future, not only for, of course, the company, but also for things that required by our community. This is a portfolio of Alloy. So the components or the technologies that we built in automotive industry so far for the last 4 to 5 years. So we've been supplying a number of different technologies. And then in EV alone, we have quite a lot of activities. So our core business competence is in development of materials. So we use machine learning, artificial intelligence to develop our new materials. And then that be applied to different components, and then we then supply these components to worldwide manufacturing in the world. So some of them are in Japan, in Germany, in the UK, and also in the USA. We start working also with a group of company in Indonesia and also in Singapore. Last one on the introductions, and then kind of trying to link up what I do, and then hopefully this can provide some insights of what engineers do. I also partly involved in building this research center under the auspice of Oxford University. The center itself is located in Japan. So we built this in the last 5 years. And our main focus is the development of some part of electric vehicle, especially the motor part. So we have around 40 people within the center located in Shimane, which is a center for development of metals in Japan. Especially Shimane is very known in Japan as a place where samurai originated. So samurai is made by technology where, even though it was first developed around 1,000 years ago, but they do develop very fine technologies with that. We built a center there, and then focusing on development of jet engine and also motor for electric vehicle. So these are ranges of activities for those of you who are in mechanical engineering, in electrical engineering, or electronics engineering, in informatics, or computer science, and civil engineering, and of course also in mechanical engineering. So there are a lot of different things that you can do. And then how this can relate to your decisions on where you want to be in the future. So this is something which I will try to deliver during my today's lecture. So I divided the lecture into 3 parts. The first part is about what lies ahead as an engineer. So how engineering is being developed or developing in the world. And then 2 is about how to build strategy of electric vehicle ecosystem in Indonesia. And then the 3rd one is I will come back to what does it take to be a world-class future engineer. So hopefully this could motivate you to work hard on your field and then be part of the development, not only in Indonesia, of course, but also worldwide, hopefully. So let's start with what lies ahead. So this graph on the left-hand side, hopefully is something that you probably may have seen. So on the y-axis, this is the speed of technology change. And then x-axis, you see that with respect to time, the development of technology is nowhere linear. It is non-linear. So the trajectory of growth is like this. And then what are the technologies causing this development? There are a lot of new technologies identified as technologies that change very fast. So including biotechnologies, and then artificial intelligence, robotics, 3D printing, ICT, mobile technology, those sort of technologies, which as you can see around here, is probably even developed more than what Moore's law is. You may probably heard about Moore's law. So it says that the power of chips, bandwidth, and computers doubles approximately every 18 months. So you could imagine that our development of computers today will be doubled by 1.5 years from now. So that fast development is something that's happening at the moment. And then when you join the engineering world, these changes is something that I can assure you that will still be kept moving. So this is what I used to teach. So I was teaching at Lady Margaret Hall at the Oxford University, teaching engineering students. I used to use these words for my students, saying that engineering technologies, yes, they do grow exponentially. So this is something, a fact rather than fiction. but yet still nowhere near the base of our ideas. So I do believe that human ideas even can move faster than this. So if you do have ideas, so in Oxford, the way we educate students, we do highly value ideas. So we listen to ideas and then we exchange ideas. So number one is having ideas. It's very important. So don't stop for people who like to think about new ideas, because ideas is key for technological change, and it may probably change your life as well. Second thing on the what lies ahead, I think hear this many times, so I don't want to go into probably too deep, because it's probably good for a specific discussion on this, which is the digital part of the world. So here is what we call it a digital compass, where a lot of different contributions affecting the way efficiency, accuracy in terms of manufacturing will be improved by this. So you can see that Indonesia is growing very fast. And then one of the key technology component that can help is actually engineering. So if you can pick a field that you see that will be important for that transformational changes, do concentrate on that. You may find a good field that excites you both, needed by Indonesia, and maybe also very useful for your future career and also your future wealth. So helping people in a way that we can contribute by our expertise and our passion, I think is something which is now can be done by everyone. So watch this space, the digital space, in the civil, in mechanical, of course in electrical, electronics, and also in the computer science field. Okay, now let's go to the second part of the lecture. So how to build a strategy of electrical vehicle ecosystem in Indonesia. And part of this presentation is my work at Kemenko Marves. And then this is also something that we try to put forward in the government policy for the next generations of electric vehicle development in Indonesia. As Pak Nanang mentions in the beginning of the lecture, he was completely correct that Indonesia natural resources is really, really key to this. And then because our natural resources are the world's future backbone, especially I think you hear many times about the abundant or the reserve #1 in the world of nickel in Indonesia. Nickel is the source of battery development, and this is needed a lot. And as you can see from this map, these are the locations of our natural resources in the world, in Indonesia, which are needed by the world. So it is important for us to look at these natural resources very wisely. At the moment, what happens, usually we sell these natural resources either as raw material or just after raw material. So we are not in the market of selling products of this raw material. So what happened, industry from abroad will use our natural resources, convert them into product, and then sell them in our country. So a lot of values, basically, we miss them. So how do we build that ecosystem? So this is a critical part of that. We do have material resources in nickel, cobalt, stainless steel, aluminum, copper, manganese, tin, and rare earth elements. So REE is rare earth element. But in Bahasa Indonesia, it's called logam tanah jarang. And how do we optimize these material resources so that on the right-hand side, so this is something which will happen, and then it's now happening, that more and more buses using EV battery as its main source of energy. And then not only that, we need a charger like this, where these charging stations need to be linked to renewable energy sources, such as photovoltaic or concentrated solar power or wind turbine. And also, we do need a lightweight structure, because lightweight structures allows EV car to travel further, and also development of motor and inverter. So how we transform the left-hand side into the right-hand side. So this is the gap. So here is where engineers can fit in. And then what are the technologies we need, especially on the material and manufacturing, and then design them and then make that happen. So this is where you can see how you can be useful in the future, and then be part of the ecosystem. In slightly more detail of where these materials go in the ecosystem. So you can see on the right-hand side, in terms of structure and assembly, so aluminum being used now more rather than steels for body in white. So body in white is the body of cars. The reason aluminum is more useful is because it's lighter. That if it is lighter, then you can travel further. And then also on the development of motor and EV, we do need a lot of copper. So Indonesia, we do have large resources of copper, but at the moment, 50% of them usually are being exported, because we mainly use copper for cable. In Indonesia, we don't use copper to build motor, for example. So something which we need to change. On the development of battery, at the moment, we are on the journey to develop battery in Indonesia. There is one difficulty, which is our nickel is not first-class nickel. So it's two categories of nickel. One is the first-class nickel, second is the second-class nickel. It depends on the purity of the nickel itself. So we do have the potential, but we still need to convert them into opportunity, and then that opportunity to help our economy. We do need a lot of electric charger stations, because otherwise people will be difficult to charge their cars. And this will involve development of charging points, and also how to connect them to renewable energy. So not only we can develop a lot on the product front, we are also expected to provide more resources from energy that comes from renewable energy front. So one of which is wind turbine, developing more wind turbine. We can use a lot of copper and steels, photovoltaic, which is for solar. We can use also aluminum for concentrated solar. We can use aluminum, glass, steels, nickel alloys. So all this, if you look carefully, so how we can then move forward from being a country that produces a lot of natural resources, but mainly we don't use them to develop products. So we need to change that, number one. And then second, we need to use that opportunity to be part of international supply chain. So being part of international supply chain is important, meaning that you need to be qualified in terms of quality. So when you develop your product, that product should be able to be sold internationally, and that requires that product to be qualified. And this is key for Indonesia. But I would say that not only we see outwardly, but we should also see inwardly. So we need to be able also to help what we call it local energy ownership. So supporting villages, islands to build self-sustainable energy ecosystem. In Bahasa, we do have programs called Desa Mandiri. So local villages can produce their own energy, and then people can live with those energy independent. So how then that creation of product, renewable energy relate to economic growth. So this is one example on the right-hand side. Let's start with if we produce nickel in Indonesia and then we sell it as is. So the nickel will just cost us, $1. So it's easy to remember. So $1 for per ton nickel when the nickel is raw. And then when we sell them in different stages, as you can see that when it is a precursor, so precursors like powders. And then there is some development in the middle where we transform this raw nickel into precursor. But even if we can sell as precursor, it will be 25 or 30 times the price of the raw nickel. And then if we move higher up in the chain, when it becomes electric vehicle, for example, the part of the nickel that we sold for $1 will be equal to around 1,000 times of what we sold as a raw material. So the value of the nickel, when it becomes a car, it becomes almost 1,000 times. So you can see that there's a huge, massive jump in terms of value when we sell something raw and when we sell as a product. So when you sell cement and then when you sell a house, for example, just to give you an analogy, the value will increase. So the increase of this value at the moment is being cut around very early in the beginning of the journey. So we sell this to overseas industries, and then Indonesian consumer market will purchase electric vehicle for the cost that they sell for. So the value's gone basically, and we just become a consumer. So what we need to change this is how we can narrow this gap and then fill in with our expertise. So there is where engineering can change and then help Indonesia. This is a little bit more detail on what are the materials on the left-hand side, elementally, and then how these are needed for different of product in electric vehicle, in the renewable energy. And then one critical graph is this one. So this is nickel. So blue is demand. So this is demand. And then the one, the red is productions worldwide. So not very long from now, which is in 2027. At the moment, we can nickel productions and demand about the same. So we can supply to what the demand is. But soon, this will not happen, which means that soon, that dependency to nickel is getting higher while the production is going to be lower. So in that case, there will be scarcity of nickel. So strategy of Indonesia in developing nickel is really important. And then we do need people or group of people, engineers, to be able to convert our materials, raw materials, into product. And then there will be programs by the government. I think you might probably heard Jokowi mentions about TKDN. So TKDN is tingkat kandungan dalam negeri in bahasa, so that we develop our own products using our own materials and then increase the value and then get the value for our community in Indonesia. So that is very important. Right, so again, going into a little bit more detail. So some part of this is actually what we suggest to the president on how to develop our own resources and then transform them into product through several different activities, which I think you will see that very relevant to the engineering where you've been studying. So let me go one by one on how materials transform into product in terms of flow. Nickel superalloy And also part of the kind of derivative of nickel is also a very important elemental material called cobalt. So here is the material for nickel, starting from the sulfide ores, lateritic ores, until transformed into components on the right-hand side. So the constructions of plants, for example, things that you see they're still wide. So we don't have everything in Indonesia at the moment. So we need to develop some of this so that we can go into battery world. So you can see that we still have some things to develop until we develop battery. But at the moment, we are able to make some of this, like stainless steels, slab, CRC, HRC, which is hot rolled, then CR is the cold rolled one, and then billet. But as you can see, some of this needs to be done overseas. So this is where what I mentioned with the gap, so the Y and the right, which means that all these applications are most likely either we need to import or part of them need to be from overseas. So no wonder some of the cars are getting expensive, because some of this need to be imported overseas. Okay, so if we are able to transform from the left-hand side to the most right-hand side, there's a possibility that we can also control the price. So hopefully by then we can boost our economic growth for our own community. And not to mention that this flow is done for world supply as well, not only supply for Indonesia. So how those transformations in terms of nickel from the raw material into electric vehicle. So these are the what we call the tree of the development of each of the components. So it's not simple. It contains a number of connectivity and then dependencies between industries. So nothing of this problem is simple, but I think you may probably learn during your engineering degree. Engineers do love challenges. So we do need to connect this so that we can link them to the electric vehicle. This is the same, but this is geared toward batteries and then components that we have, or materials that we don't, and then how we need to plan around that. And this is what happens not very long time ago, where our government start to reduce or actually stop export of nickel, and then that changed a lot nickel price in the world. So you can see that we do have very important role in the world in terms of nickel production and export. And as you can see, Indonesia is the highest in the world. The same thing with aluminum. So you go from the left-hand side, and then with each of these processes, you will end up with products. So keep watching of this development, and then pick your product that you are interested in. Try to see where the gap, and then I think you might probably find yourself into interesting area of business or development as an engineer, or if you want to be an academic. Copper, the same story. At the moment, there are a lot of things that we don't have that we need to build. So this is some hints how engineers and also human resources in Indonesia should be developed so that we can build our own motor. So we are not able to build our own motor at the moment. Again, this is just a repeat one where all those that I explained should be be part of the ecosystem. So now this is slightly, again, because the way I structured the lecture is we go more detail as we go along. And then so that as an engineer, you see how your contributions as electrical electronics engineers, and then computer science, mechanical can fit into this, and a lot of this involving computer science. So this is for the EV battery ecosystem. This is for lightweight structure and assembly. And then this is for motor, inverter, and electric charging station. And all those will be necessary for us to make sure that the cost is as low as possible. So how to make these integrations the cheapest possible? So we identify a few things: development of networks. So this is infrastructure. System integration. So in terms of field, so the networks will be relevant more to infrastructure, so probably relevant to civil. System integrations, electrical, electronics, and computer science. And then consumer participation and protections, which is on the product itself, where the mechanical engineers can focus on. And then in terms of supplier in the world of EV, as you can see, there are a lot of them, and then they do share quite distributedly instead of very focused, just one or two manufacturers. And look at this. So this is worldwide kind of movement towards using electric vehicle in the world, and they do share different concern. So this is also a point where we cannot just copy what happens in the UK, in Japan to Indonesia. We do have our own characteristics. So there you have the gap that Indonesia needs us to understand the characteristic of our community and build the strategy based on our condition. This is in the UK, where in the UK, if you buy electric vehicle, you will get contributions of money from the government so that you can buy electric vehicle cheaper. In Indonesia, we do have several different ways to achieve this, but essentially we do need to build a strategy around this. Now, after all that strategy discussions on electric vehicle, what will be the next step? Many of these will be more relevant for industry or government, but I think for this lecture, one very important is talent. So I think we need to be able to improve this, so skills, and also investment to improve our talent. So the biggest investment is your time, so your effort that you want to be part of this, especially not only in Indonesia, but also in the world. And I think that will be critical key that Indonesia very soon need. And now that comes to the third point. So how, what sort of strategy and then what does it take to be world-class future engineers? So hopefully this will relate to how do you see yourself in the future. So you may have heard about Industry 4.0. So there are lots of information on this. And then around this are autonomic robots, simulations, additive manufacturing, big data, and analytics. Now, how to be part of that and then to win in that type of environment? So these are several key talents needed. So number one is adapt to changes quickly. So you should be able to see yourself changing from one condition to another, adapting yourself to the changes quickly. So if you see yourself as someone who can do that, you are in a good conditions. And then, although you are mechanical engineers, so don't forget that coding or computer science is become more and more ubiquitous. So more and more people using it, like people using bicycle. So do learn coding for everyone, civil and mechanical. Computer science, we learn this a lot, but also people in electric should also be good at it. And then next is it is important to be creative. So creativity is the new goal, meaning that If you're creative in engineering, it is a very good recipe, okay? Because you may be able to transform that into opportunity, which may help our community. So do creative, do be creative. And then another strategy is that see yourself having different building blocks. So it's not only communications, but also programming, computer skills, attention to detail, and so on. So build this step by step, even during your study. So even if it is not in your curriculum, have a look on this. You should build this along with your expertise, okay? And then there is one word which I can probably explain quickly. So this is a program in the UK actually. So they want engineers to have hybrid skills. So by hybrid, it means that engineers should have combined technical and commercial competence. So not only we are good at the technical, but we know how to turn technical products into commercial market. And this skill is more and more important. So if you do like sell, because when I was at ITB, when I was in my university, I spent most of my time in the first 2 years building cooperative, in my university, selling clothes. And if you go to ITB, you can see people want to buy ITB t-shirt. Or I also sold a lot of souvenir. I was in charge of small store there, and I used also to sell books. And that type of things now I understand very useful for my career in the technical side, converting that into commercial aspects. So if you do have that type of opportunity, do that. Some of you may probably sell online. Don't worry, that that is also count. So you need to think about strategy, how to kind of make your products fit. So not necessarily initially with technical products, but could be with anything. So if you like that, I think you might probably find yourself a hybrid engineer in the near future. But then all this should lead to leadership. So if you have chance to lead small organizations in university or leading your team, try your best to have that experience if you like it. So all these hybrid skills, engineers, technical, commercial, leadership, if we combine all, this is a good recipe to become entrepreneur, which is in Indonesia we call wirausaha. So I started building from quite long time ago, and then bit by bit that helps me to see how innovations can transform into commercialization. So how many people in the world are entrepreneurs? Apparently from this chart, it is 400 million people, so double the size of Indonesia almost, of the 7 billion people. So it's actually just around, so the 10%, 5%, 4%. So it's quite low. But if you, one of them, you may see that this is one gap that you might be interested in. So just last one slide to, then the question is, if I'm interested, not everyone should be entrepreneurial. So you could be a very good engineer, you could be a very good lecturer, and understand where the gap is and then how you can use your expertise and then be part of increasing the values for Indonesia and then for the greater good of the world. However, if you're interested to become an entrepreneur, so entrepreneur is not necessarily just selling non-engineering goods like clothes or those sort of things, but also can focus on the engineering products. So I will give a takeaway 2 questions. So this is a slide that I used to teach at Oxford University. I teach also entrepreneurship in the university, where we start with these 2 questions. So number 1 is, how much societal or customer value is created. So with your product, how much value you are creating. So this could be, do end user find service product valuable, or how much will they actually pay? So the value is key. So when you sell products, you sell services, or anything that you transform your ideas into commercialization, always ask the value. So why is the value? So the value is not always money though. So the value could be someone who needs a solution for their health will get a solution, for example. Someone who needs to do exercise can do exercise. Those sort of value. Okay, look at the value. And then number two, this is sometimes overlooked. So scalability of your product. So can the venture scale? Because in business, you do need to scale, because otherwise it won't last long. Okay, so how many customers will pay? Can one make enough profit? Okay, so just with these two questions, if you can answer correctly, maybe a good point to start your journey. And yeah, so I think that's a good wrap up for today's lecture. And then I do believe that Indonesia becomes more and more important to the world. And now it is the world to wake up to Indonesia. And if you have any questions, do let me know. Thank you for joining the lecture. Yep, so Dr. Fitri, shall I stop my screen? Yeah,
Okay.
Just leave it to you then.
Okay, thank you very much, Dr. Fauzan, for the presentation. Yeah, this very nice and also interesting topic. So I will not add another conclusion because already mentioned. Now with the time to take the question from the audience, we have Dr. Anton already raised the hand. So please open your mic.
Okay, thank you very much for your lecture and insight about electric vehicle and what would be the prospect in Indonesia. Can I ask you with bahasa?
Yes, silakan.
Ya, okay. Jadi ada dua pertanyaan, yang satu agak serius, yang satunya agak bercanda. yang serius dulu ya. Jadi dulu tuh waktu kuliah itu mungkin karena tahun 2015-an lah ya. Itu di situ dosennya dari electrical lagi membahas sebuah power design kayak gitu. Cuman pada saat itu mungkin teknologinya masih belum sebagus sekarang gitu. Jadi saya ingin konfirmasi mengenai efisiensi vehicle antara hybrid, elektrik sama combustion engine gitu. Jadi waktu dulu sih bilangnya yang elektrik tuh masih belum sebagus combustion engine, dan yang paling bagus itu adalah hybrid kayak gitu. Nah, kalau sekarang itu bagaimana ya Pak? Apakah sudah berubah atau masih sama? Bagaimana perkembangannya saya belum tahu. Nah, untuk yang kedua nih yang agak bercanda itu, saya sekarang lagi di Taipei. Jadi di sini memang ada bus itu dia electric vehicle kayak gitu. Di sini tukang bus, supir bus itu ugal-ugalan ya. yang pakai mesin combustion engine itu ugal-ugalan. Terus kalau yang pakai electric vehicle dia lebih ugal-ugalan kayak gitu. Nah itu gimana kalau di UK kayak gitu? Apakah ada perbedaan atau gimana? Jadi itu sharing pengalaman yang kedua. Iya. Paling itu aja. Terima kasih.
Terima kasih banyak Pak. Terkait efisiensi, jawabannya memang sekarang perkembangannya itu sangat pesat ya Pak Anton. Kebetulan kita juga terlibat di salah satu teknologi yang dikembangin oleh tim kami di sini di Oxford itu. Kita juga supply untuk tim F1 di Inggris. mereka karena kalau F1 kan masih lebih pakai combustion ya, jadi peningkatan efisiensi itu jadi sangat kritikal. Dan juga kita kerjasama dengan manufacturer terbesar ya di dunia yang ada di Jepang. Mereka juga tetap ingin meningkatkan efisiensi combustion itu. Jadi kompetisinya itu terus meningkat tahun demi tahun gitu. Memang agak sulit untuk membandingkan di saat yang fix gitu, combustion selalu di bawah. Ternyata enggak juga, karena combustion itu sekarang caranya untuk menaikkan efisiensi itu dengan meningkatkan temperatur material yang bisa dipakai, dan di situ juga sebetulnya awal masuknya bisnis alloy awalnya. Jadi kita menemukan material untuk turbocharger supaya bisa dipakai di temperatur yang lebih tinggi. Jadi kalau temperatur yang lebih tinggi, efisiensinya lebih tinggi. Nah, buat rekan-rekan mahasiswa, maksudnya efisiensi itu apa? Efisiensi itu berapa banyak yang dari proses kita menggunakan mobil yang terbuang dan tidak bermanfaat untuk proses transportasi. Biasanya keluarannya bisa jadi polusi. Nah, ini bisa ditekan dengan berbagai cara gitu ya, termasuk juga adanya turbocharger. Turbocharger itu membuat engine lebih kecil tapi jadi lebih efisien. Sedangkan di baterai, sekarang efisiensi terus ditingkatkan dengan sebisa mungkin itu baterai mempunyai antara kapasitasnya dan jarak tempuh yang lebih jauh dan lebih jauh lagi. Dan ini terus berkembang juga hari demi hari. Jadi ini sangat cepat perubahannya. Ditemukannya baterai yang baru, terus juga apalagi sekarang ada, pernah juga mungkin mendengar kan banyak itu suka bilangnya lithium baterai ya, tapi sebetulnya ada baterai jenis lain yang lebih efisien lagi, jadi dia lebih ringan, hanya saja pembuatannya sekarang masih terus berkembang ya, namanya solid state battery. Jadi sekali charge bisa 800 km gitu. Sekarang sekali charge itu untuk besar baterai yang bisa masuk di mobil mungkin di kisaran 200-300 untuk yang baterai tipe menggunakan material yang lebih murah gitu ya, yang lebih mahal itu bisa sampai 400-500 km gitu sekali ngecharge. Cuman ini terus berubah juga. Nah, sekarang hybrid sebetulnya karena di tengah, dia bisa menggunakan yang terbaik antara keduanya. Jadi Pak Nur betul, yang hybrid itu bisa lebih efisien ketika engine dan baterai bisa bergantian penggunaannya. Hanya aja kenapa pemerintah Indonesia sekarang lebih fokus ke electric vehicle dan juga di dunia. Jadi hybrid masih ada, hanya aja kita memproyeksikan ini kan akan tidak terlalu berkembang seperti berkembangnya baterai, karena masih adanya ketergantungan dengan combustion engine. Jadi di Inggris mulai tahun 2030 ini sudah tidak akan lagi dijual mobil combustion engine. Jadi mobil yang kita lihat di Indonesia banyak, di Inggris itu akan tidak lagi dijual di 2030, nggak lama lagi. Di Inggris sekarang jumlah penjualan mobil electric vehicle, kebetulan saya 2 minggu yang lalu ikut conference, angka terbarunya itu sudah 18%. Jadi bayangkan ada 10 mobil, 2 itu di Inggris sudah electric vehicle. Di Indonesia kita masih sangat rendah, tapi biasanya kita akan pick up juga momentum ini gitu. Jadi ya walaupun secara efisiensi masih terus berkompetisi ya satu dan lain, tapi kelihatannya akan menang electric vehicle. Karena pemerintah sudah mulai akan, nggak hanya di Inggris, banyak negara-negara di dunia juga yang memperlakukan penjualan internal combustion engine itu berhenti di mulai 2030. Bahkan yang paling cepat itu di 2027 dan lain. Beberapa manufacturer juga sudah seperti di Inggris, Land Rover itu sudah komit 2027 itu udah nggak lagi produksi yang non elektrik. Jadi akan bergerak ke sana. Jadi secara efisiensi jawabannya berubah dengan waktu ke waktu. Combustion engine tetap juga ingin tetap eksis, tapi kita melihat akan berkurang mulai 2027 kira-kira 2030 kalau di dunia ya, itu mulai banyak yang akan stop produksinya. Dan itu akan membuat impact juga ke Indonesia. Untuk yang bis di Taipei, saya kebetulan belum pernah. Waktu itu sebetulnya kita nggak jauh ya, kalau saya lebih lama di Jepang. Mungkin karena yang electric vehicle ini cenderung kan otomatis ya, apalagi bis kalau di Indonesia ya ada yang otomatis, itu kalau di luar banyak yang otomatis. Jadi mudah untuk kayak main bom bongkar gitu kalau kita di kepala. Jadi ya untuk ugal-ugalannya lebih gampang. Hanya aja kalau di Inggris karakteristiknya itu sangat patuh lalu lintas. Jadi mungkin negara yang paling yang saya tahu lah gitu yang sangat patuh lalu lintas Jepang. Jepang itu yang kalau nyetir paling gampang. Di Inggris mungkin mirip-mirip kayak gitu. Jadi di sini kalau nyetir, jadi saya karena sekarang berapa tahun ya, sudah 11 tahun di sini. Kalau pulang ke Indonesia udah mulai nggak bisa nyetir lagi gitu, karena di Indonesia buat saya waktu itu bingung saya sama motor itu mau gimana ini, karena di sini sebegitu patuhnya. Jadi entah gimana di Inggris itu orang sangat patuh di lalu lintas karena pemerintahnya sangat strict. Jadi ugal-ugalan banyak juga memang bis-bis elektriknya di sini. Itu nggak dominan. Mungkin juga di kota saya nggak tahu juga kalau di London misalnya gitu ya, atau di kota-kota yang lebih besar. Mungkin juga yang ugal-ugalan. Begitu Pak Anton, mudah-mudahan menjawab.
Ya, terima kasih Pak.
Terima kasih.
Okay, thank you. Terima kasih Pak Anton dan juga Dr. Fauzan. Is there any question from the audience? Maybe the student? Okay. We have questions in the chat. Dwinto. Yeah. This is, you can use your microphone or directly. Yeah.
Ya,
Please free. Ya, boleh dalam bahasa Indonesia.
thank you Bu Fitriana.
Ya, silakan.
Saya Dwinto, Pak Fauzan, izin bertanya. Yang pertama tadi Pak Fauzan menyebutkan tentang strategi ekosistem electronic vehicle di Indonesia. Sejauh yang Pak Fauzan tahu, tadi juga kan mengutip dari Kemenko Marinvest ya. Apakah sudah ada dukungan secara regulasi ya di Indonesia untuk peralihan dari kalau istilah saya mungkin yang awam kendaraan BBM ke arah electric vehicle ini Pak secara masif. Dan kalau tadi disebutkan di Inggris itu 2030 mulai dihentikan ya kendaraan yang saya tangkapnya BBM mungkin Pak ya.
BBM,
saya kebetulan
BBM.
latar belakangnya dari ekonomi. Mohon maaf kalau istilahnya salah. Nah, kalau di Indonesia sendiri di tahun berapa itu akan ada keputusan yang pasti gitu, angka tahunnya akan ada penghentian kendaraan-kendaraan BBM ini? Terima kasih Pak Fauzan.
Ya, terima kasih Mas Dwinto atas pertanyaannya. Di Indonesia untuk regulasi sekarang ini bergerak dengan cepat ya. Kemarin saya tuh 1 bulan yang lalu sih sekarang habis Lebaran kebetulan ada meeting di Bali waktu itu membahas terkait ini salah satunya. Dari meeting itu yang saya pelajari untuk motor regulasinya itu sudah beres. Jadi percepatan motor ini di Indonesia akan sangat kita lihat gitu, akan percepatannya sangat tinggi karena nomor 1 sebetulnya di Indonesia itu masalahnya biaya kendaraannya. Jadi belum murah ya, terutama kalau mobil, karena yang paling murah aja sekarang sekitar kalau nggak salah ya Hyundai itu 600-700 juta rupiah, di mana itu di luar dari budget untuk masyarakat umumnya di Indonesia. Sedangkan untuk motor, sekarang motor gesit itu sudah bisa dibeli dengan harga yang tidak jauh dari motor BBM. Nah, ekosistem motor juga sekarang sudah membolehkan. Nah, ini juga mungkin menjadi informasi untuk engineer ya yang suka ngotak-ngatik motor nih, karena pasti banyak yang punya motor, sudah bisa dikonversi motor BBM ke motor EV dan itu sudah ada aturannya. Jadi aturannya sudah membolehkan dan sudah dibuat standar. Jadi ada 2 ya, 1 lihat regulasi, 2 lihat standar. Jadi standar nasional Indonesia itu sudah selesai untuk bagaimana motor BBM bisa menjadi motor electric vehicle. Di situ mungkin ada kesempatan-kesempatan bisnis juga gitu, terutama buat rekan-rekan yang senang. Apalagi sekarang rekan-rekan mesin yang bisa bekerja sama dengan rekan-rekan di elektro misalkan gitu ya. Jadi kalau urusan motor, transformasi masif ini akan berjalan dengan cepat di Indonesia. Regulasinya sudah ada. Tadi juga Pak Nanang menyebutkan ya di bagian lecture di awal bahwa sudah ada peraturan pemerintah untuk percepatan kendaraan berbahan baterai ini. Jadi saya sendiri sebetulnya ikut gabung di tim yang diketuai Pak Satrio, itu tim untuk percepatan kendaraan berbahan baterai ini, dan tim ini sangat aktif sekarang. Untuk mobil, untuk mobil kita masih ada kesulitan karena supply chain-nya nggak bisa kita kontrol sendiri gitu ya. Jadi kalau motor kan baterai gesit sudah bisa buat sekarang misalkan, dan bagaimana supaya bisa terjangkau kan sekarang ada baterai swap ya. Jadi daripada di charge tinggal pergi ke mana begitu, mungkin ke Indomaret mungkin nantinya tinggal ambil swap masukin gitu kan, nanti bayar berapa gitu. Jadi bisa instan. Kalau mobil, masalahnya biaya mobilnya masih tinggi, jadi PR-nya itu sama dengan di Inggris ini, bagaimana menurunkan harga mobil listrik. Nah, di Inggris ini sudah mulai dari sekitar 3-4 tahun yang lalu ya programnya, mereka memberi subsidi. Nah, di tahun ini di Inggris itu biaya mobil listrik sama biaya mobil BBM, terutama maintenance dan lain-lainnya, itu di angka yang sama. Jadi sekarang di Inggris maka itu sekarang jumlah, kemarin juga nih karena saya baru ikut konferensi, jadi jumlah tipe mobil listrik yang dijual di Inggris hari ini itu ada 69. Jadi saya juga baru tahu banyak sekali ternyata. Jadi dari mulai VW elektrik terus juga macam-macam lah ya, ada 69. Kalau di Indonesia mungkin sekarang 45 gitu ya di bayangan saya, dan masih mahal-mahal. Di sini sudah hampir 70 gitu. Jadi akan datang juga Mas Pinto. Nah, apakah pemerintah sudah memberi hint gitu kapan kita akan berhenti? Di Indonesia sayangnya belum bisa sekarang. Jadi kalaupun bisa, bayangan saya, ini bukan bocoran atau apa-apa, menurut saya kita akan telat mungkin di angka 5 tahun atau 10 tahun. Karena yang sulit juga masyarakat kita sendiri nanti. Jadi kita harus hati-hati dan belum ada kapan kita akan memberhentikan. Dan ini juga masih kebetulan saya secara terpisah terlibat pengembangan teknologi ya dengan industri di Jepang. Mereka juga sangat concern terutama karena mereka memiliki plan-plan di negara berkembang seperti di Indonesia. Jadi kalau langsung pindah ke EV, plan-plan yang di Indonesia ya yang bikin mobil itu akan berhenti, dan kalau itu berhenti banyak orang kehilangan pekerjaan dan lain-lain. Nah, maka itu kenapa penting bagi engineer melihat arah ini supaya jadi bisa melihat nanti kalau mau ke depan pilih bidang apa yang perubahannya itu membantu, dan ada juga kita bilang hal-hal teknologi yang sudah sunset gitu ya istilahnya, sudah mulai mau berakhir gitu. Jadi coba lihat-lihat teknologi tersebut dan pilih gitu. Jadi gitu Mas Winto, belum kalau di Indonesia, dan secara regulasi ini sudah banyak ya, bahkan Presiden Jokowi juga sudah membuat berbagai peraturan untuk mendukung proses elektrifikasi kendaraan di Indonesia, termasuk konversi pengurangan BBM menjadi kendaraan elektrik. Terima kasih pertanyaannya Mas Yanti. Ya, sama-sama. Oke.
Terima kasih Bapak Fauzan dengan Pak Dwinto. Apakah ada lagi pertanyaan yang ingin ditanyakan kepada expert kita hari ini? Mungkin satu pertanyaan lagi. Oke, silakan Ibu Tika, sudah raise hand.
Ya, terima kasih kesempatannya. Ini saya online bersama dengan mahasiswa.
Di kelas ya, Mbak.
Ini diskusinya biar diskusinya langsung, Pak, karena terkadang
silakan.
Bingung gitu ya, Pak. Kalau saya rangkum sih, Pak, ya, dari mahasiswa ini. Jadi tadi kita berdiskusi, Pak. Jadi mindset ataupun pace-nya Indonesia itu mungkin ya, Pak, dari beberapa diskusi dengan anak-anak di sini itu lebih pada negara agraris, negara
pariwisata, ya.
Penelitian-penelitian atau ide-ide yang keluar itu lebih pada mesin-mesin yang mendukung ke situ, Pak. Jadi waktu saya cerita, ini nanti kalau Inggris 2030 akan berbukti, kalian berarti harus siap-siap ini di bengkel
betul.
Setidaknya motivasinya sudah ke arah situ di ide-idenya. Kalau kita mau menjawab tantangan masa depan, ya Pak, jangan sampai industri yang dibangun di Indonesia mahasiswa sendiri nggak ada ini kan electrical vehicles. Jadi kalau tadi cerita brand, kira-kira seperti apa sih Pak caranya agar brandnya Indonesia ini bisa berubah dari brand yang pariwisata, agraria, ke negara yang bisa menjadi penghasil energi, melek teknologi gitu Pak, sehingga mahasiswa mulai berpikir penelitian-penelitian yang membuat mereka mau ke arah itu gitu. Ketika industri itu sampai ke Indonesia, yang isinya memang warga ini calon-calonnya mahasiswa kita yang ada di teknik, kira-kira membangun brand itu seperti apa? Sekian dari saya Pak.
Ya, terima kasih Bu Tika. Dari pertanyaan yang saya tangkap, Indonesia ini kan sekarang lebih dikenal ya, dan juga kita juga mengetahui gitu ya, banyak yang lebih berkecimpung di agrari, di pariwisata, dan di teknologi-teknologi yang berbasis dan untuk memotivasi juga ya untuk mahasiswa dan engineer kita untuk bisa melihat perubahan ke depan sehingga Indonesia juga bisa dikenal menjadi negara yang berbasis teknologi. Sebetulnya sekarang itu Indonesia, kalau saya lihat gitu ya, dari perbandingan Indonesia, karena mungkin bagusnya dari sudut pandang saya, karena kalau saya ke Indonesia itu saya bisa melihat perubahan, sedangkan mungkin kalau saya ada di Indonesia perubahannya karena sehari-hari jadi mungkin nggak kelihatan gitu. Jadi kalau kita karena datangnya setahun cuma sekali gitu, jadi saya bisa melihat perubahannya seperti apa. Nah, jadi dari sudut pandang saya, sebetulnya di Indonesia itu perubahan yang sangat signifikan itu bagaimana Indonesia itu begitu cepatnya mengadopsi digital ya, digital teknologi dalam hal Gojek aja, Gojek, Grab, dan lain-lain itu buat orang asing, Indonesia itu sangat maju. Jadi pembayaran finance pakai HP, terus Gojek itu bisa di desa-desa pakai app dan lain-lain. Sebetulnya itu menunjukkan bahwa Indonesia itu transformasinya itu bisa sangat cepat. Jadi ini untuk analisis pasar sebetulnya sangat positif. Artinya kita mempunyai mass atau kekuatan untuk transformasi. Jadi kalaupun transformasi ini berjalan untuk beberapa hal tidak secepat tadi gitu ya, menggunakan app dan lain-lain, saya yakin kita memiliki sumber daya manusia itu yang bagus ya untuk membuat perubahan itu. Jadi nomor satu, kita ini jangan rendah diri di dunia internasional. Jadi kadang-kadang kita melihat dunia internasional mungkin terlalu tinggi gitu. Jadi di sini juga banyak di luar negeri yang pendidikannya rendah, nggak belajar tentang teknologi dan lain-lain gitu. Jadi nomor satu, bahwa sumber daya manusia Indonesia itu memiliki kemampuan yang kalau menurut saya. Nah, berbasis itu tinggal tadi untuk secara strategi dari untuk menjawab pertanyaan itu. Kayak yang pertama itu interdisciplinary. Jadi kalau di kampus belajar mesin jangan hanya belajar mesin gitu ya, tapi juga membuka diri, oh kalau elektro itu sebetulnya belajar apa aja gitu ya. Jadi mulai bisa melihat interdisiplin gitu ya, belajar yang lain. Bisa juga belajar tentang akuntansi gitu ya, atau belajar tentang bengkel juga nggak apa-apa. Hanya aja mungkin kalau bengkel, nah ini nyambung ke poin nomor 2, kita harus bisa adaptasi. Jadi nomor 1 interdisciplinary, jadi belajar mulai interdisciplinary. Yang kedua itu bisa melihat bahwa adaptasi itu sangat penting. Artinya ketika kita tahu misalkan udah bakal berkurang nih bengkel gitu ya. Karena kemarin saya kebetulan karena di Bali ini kan sebentar lagi ada G20. Jadi di sana coba disiapkan industri dalam provinsi Bali itu apa yang bisa membantu untuk perubahan ekosistem ke electric vehicle. Ternyata kita bisa mengkonversi beberapa bengkel menjadi bengkel konversi dari motor biasa ke motor elektrik gitu. Dan untuk perubahan itu, bahkan kemarin pembahasannya kita akan coba membuat training. Nah, ketika ada training perubahan skill seperti itu, nah kita harus siap beradaptasi gitu ya. Jadi ketika ada perubahan, jangan menutup diri, tapi membuka diri. Oh, apa perubahannya? Saya siap belajar. Jadi siap belajar hal yang baru, beradaptasi itu sesuatu yang sangat diperlukan. Yang ketiga ini yang menurut saya, bahkan kemarin ya sering saya bicara, terutama yang universitas yang banyak berinteraksi ya, terutama di ITB, di Universitas Pertamina, dan nanti juga mungkin lewat Fitri saya bisa membantu untuk bagaimana sebetulnya dari proses mahasiswa udah kita coba tanamkan ini gitu. Jadi salah satu yang sering saya bilang itu minimum nih ya, lulusan teknik mesin yang umumnya biasanya dulu nggak menyentuh programming itu bisa Python misalkan. Python itu programming yang bisa dipelajari di YouTube dalam setengah jam. Jadi ada rule of thumb yang bilang bahwa kalau untuk mempelajari sesuatu semua orang itu bisa ya, paling nggak untuk mengerti dasar-dasarnya itu dalam 30 menit. Jadi mungkin bisa digunakan tuh. Jadi kalau memang mau apa sih itu Python programming, sudah siap-siap bawa kopi, bawa minum, 30 menit saya buka YouTube atau yang gratis banyak karena sekarang ya, belajar. Di situ nanti akan kelihatan gitu. Jadi 30 menit aja coba dimulai belajar hal yang teknologi yang bisa membantu kita nomor 1 jadi lebih interdisciplinary, kita bisa beradaptasi, dan juga speak code itu bahasa Indonesianya mungkin melek coding gitu. Jadi lebih bisa belajar coding untuk mahasiswa ya, untuk menurut saya, karena kalau coding itu kita bisa kita tidak perlu biaya infrastruktur yang mahal, terus kita bisa bertanding langsung dengan engineer-engineer di Amerika. Kebetulan perusahaan yang saya kembangkan, saya itu merekrut engineer dari berbagai belahan dunia gitu. Jadi karena saya kadang-kadang nggak perlu ketemu mereka juga. Jadi engineer saya ada di Amerika, tentu di Inggris banyak, di Jepang, engineer saya ada juga di Indonesia, dan juga di India sekarang biasanya saya coba rekrut gitu ya. Nomor 1, asalkan mereka bisa qualified, dan bagusnya dengan berinteraksi dengan kita juga bisa meningkatkan lokal ekonomi gitu. Nah, jadi gitu. Kalaupun saya bisa kasih tips dan trik, 1, siap belajar hal-hal yang baru ya, dan beradaptasi. Jadi kalau ada perubahan, siap untuk itu. Persiapkan 30 menit aja. Awali untuk belajar misalkan software gitu ya. Bisa Python atau nanti C# atau C++. Itu tips dan yang trik yang bisa saya sarankan gitu ya buat kita. Kalau banyak mahasiswa kita bisa seperti itu, saya pikir transformasi ini akan terus berlangsung. Saya bisa melihat hari demi hari transformasi industri di Indonesia ini bergerak ke arah yang positif gitu. Jadi ini akan terus berlangsung. semua itu akan tergantung dari sumber daya manusia. Jadi akan selalu dicari sumber daya manusia yang siap terhadap perubahan-perubahan ini. Nah, ini mungkin bisa jadi salah satu fokus di Wika ya, untuk bisa membantu ekosistem mahasiswa mempersiapkan perubahan-perubahan yang akan terjadi di Indonesia, menjadi agen perubahan. Mudah-mudahan membantu jawaban ketiga. Kalau ada lagi silakan.
Ya, terima kasih banyak ini untuk yang bertanya Ibu Tika dan juga penjelasan dari Bapak Fauzan. Ini diskusi yang sangat hangat dan kalau bisa diperpanjang ya, topik ini memotivasi tidak hanya bagi dosennya, tapi juga untuk mahasiswanya supaya punya pemikiran yang lebih terbuka lagi ya, terutama terhadap perubahan. Mungkin nanti Pak Wadek kita bisa buka session yang lain ya, yang khusus untuk hal-hal begini ya.
Ya, silakan.
Nanti ya khusus ya. Maybe we are now in the end of this session. So before we close our class, so we take a photo maybe to as the documentation. Okay. So siapa ya Pak yang ambil?
Helmi, dihitung aja sama Ibu. Oh ya, oke. I will count 1, 2, 3. 1, 2, 3. Correct. Okay, next slide. 1, 2, 3. Correct. Okay. Last slide. 1, 2, 3. Correct. Okay. Sip.
Okay.
Terima kasih.
Okay, thank you very much, Pak Setia. So we are coming to the end of this session. On behalf of the Faculty of Engineering and Science, Universitas Ibnu Khaldun Bogor, I would like to thank you, Dr. Fauzan Aziman, who already shared his knowledge, his experience, and also his expertise with us today. And also for all attendees, I would like to say thank you, sincerely thanks. So I close this session. Hopefully we can meet again in the next sessions. Assalamualaikum warahmatullahi wabarakatuh. Bye bye.
Waalaikumsalam.
Waalaikumsalam.
Thank you.
Waalaikumsalam.
Thank you.